Welcome to Connected World, a podcast for engineers to learn more about the trending topics influencing the connected world and technology turning today's impossible into tomorrow's awesome. Hello and welcome to Connected World, a podcast from TE Connectivity. We're glad to have you joining us for this episode of the program. Today's conversation is going to center around RF technology, what it is, common applications, and major trends. Joining me for the conversation today is Amos Cheah. He is the Senior Manager of R&D and Product Development Engineering at TE Connectivity. Amos, thanks for joining me.
Yeah, thanks for asking me to join the podcast.
Absolutely. Well, I'm excited to get your insights on the show today. So, Amos, let's just start off at the most basic level. Explain what RF technology is and why it's important.
Yeah, okay. I will try to explain this. So I would like to explain RF technology in this way. So let us understand first what is RF mean, right? So RF stands for radio frequency. So radio frequency, which refer to radio wave, a designation for electromagnetic wave that are both above the hearing range of human ear, about 20 gigahertz, and extend to just below the infrared region of light. It's about 300 gigahertz. So radio frequency propagation occurs at the same speed of light and can travel in the absence of any medium like air. So when it comes to RF or radio frequency technology, we are talking about a wireless electromagnetic signal that is used as a form of communication in wireless electronics. So RF technology is of knowledge that describe the laws of physics that are applied to the generation, conversion, propagation, and detection of electromagnetic waves. So the description of this knowledge was set down by James Clerk Maxwell with a set of 4 equations that bear his name. So now why RF technology is important for wireless communication? So to understand this, I want to bring the importance to recognize that electromagnetic radiation is unique in its ability to extend electrical circuitry into the wireless domain. So anything that can travel through a non-conductive material, mechanical motion, sound wave, and even heat could be used as a means of converting electrical energy into information that does not rely on conductive interconnection. So now let's return to the question of why electromagnetic wave, right, its base system are so common and compared to other form of wireless communication. In other words, right, why does wireless almost always refer to RF or RF technology when various other phenomena, like just now I described, can transfer information without the aid of wires? So there are a few reasons, right? First is agility. So EMR is a natural extension of electrical signal used in wire circuit. So by time varying voltage and current generated electromagnetic field, whether you want them to or not. And furthermore, the electromagnetic wave is a precise representation of AC component of the original signal. Okay. So second is the speed. So the AC coupling system, right, at the rate at which data can be transferred, depend on how quickly a signal can experience variation. So in other words, it turned out that the EM field or electromagnetic field is a practical communication medium even at very high frequency, which means that our system can achieve extremely high rate data transfer. So thirdly, range, right? Because wireless communications is closely linked to the pursuit of long distance communication. So if the transmitter and receiver are in close proximity, it's often simple and more cost-effective to use wire. So that's why EM RF signal electromagnetic wave with a modulation technique and receiver circuitry, it have the ability to transfer user signal over long distance. And then the lastly is no line of sight needed. So only the wireless communication medium that can compete with electromagnetic wave is light. But light is actually very high frequency electromagnetic wave, which require line of sight. But RF communication, a clear line of sight is not required. So as a summary, right, there's 3 points here, right? First thing is RF refer to the use of electromagnetic radiation for transferring information between two circuits that have no direct electrical connection. So then, and it's a time varying voltage and current generated electromagnetic energy that propagate in the form of wave. So we can wirelessly transfer signal by manipulating and interpreting this wave. And while electromagnetic wave or RF frequency is dominant form of wireless communication, because it's the only alternative in the use of light. RF is much more versatile because low frequency electromagnetic waves is not blocked by any solid objects.
Fantastic. Well, thanks for that explanation, Amos. So, what are some of the more common applications of RF that we see? Is it used, for Wi-Fi routers and things like that? Kind of talk me through some of the common places where we see RF technology used these days.
Yeah, it's used in a lot of application in a lot of user case. So, in a number of industries, right, such as a radar system, remote control, television broadcasting, so remote monitoring, computer, mobile platform like mobile phone, and also like router, right? And and other any mobile platform networks. So from smartphone to stereo receiver or GPS and even more, RF technology is a feature of modern life that is so unique and ambiguous that many of us simply take it for granted. Right? So like mobile phone is become part of our life, right? So it's amazing how far that we have come in such a short time, and there is no sign of demand for advanced RF technology slowing down. So private company, even governments and military also using these around the world and are competing to have the latest in RF frequency innovation.
Absolutely. So it's a technology that is all around us all the time. It's incredibly important, like you mentioned. So what are some of the major trends that are developing in RF technology? You just mentioned the latest. So what is the latest, and what's going on as far as trends and developing in further in RF technologies?
You probably know, right? The upcoming 5G revolution that is, I think I've already heard about it. So it's one of the biggest changes on the horizon, right? So I think within these 5 years, it's a safe that we can say that 5G network will have been up and running, and consumer expectation for mobile speed and performance will be radically higher than today. And more people right, embracing smartphones around the world, and they will demand for data will continue to rise. And legacy bandwidth ranges, right, which run below 6 gigahertz, this was simply not sufficient right, to meet these challenges. And 5G frequency, that I think, in my opinion, will go up to millimeter wave and even above even 20 gigahertz. Right? That was reported right, in public. Like 5G yielded speed of up to 10 gigabytes per second, up to 73 gigahertz. So there's no doubt that 5G will offer lightning fast coverage at frequencies which were previously used only for military and satellite applications. So this 5G will make this currently available in military and satellite available in consumer. Right? So 5G network will play an integral part in speeding up wireless communication. So perfecting virtual reality and connecting millions of devices we use today, it will be the key to ushering in the Internet of Things that you also heard about right currently, in which countless household products, handheld electronics, wearable devices, robotics, sensors, self-driving vehicles, and more will be connected through network speeds significantly faster of today. So the bottom line is that in the future, I think it's very bright for RF technology, and the demand for radio frequency engineering is high. So the next 10 years, we will see enormous growth and innovation in this industry.
Absolutely. There's been so much conversation around 5G and the impact that it's going to have and the challenges in making it happen. So, how will the trend of 5G moving forward have an impact for engineers? And how will they create, how will 5G create challenges that engineers need to overcome during this time?
Okay, there are many challenges that need to address when we move towards 5G standard, which demands much higher data rate, so ultra low latency, high reliability, and security. So as we know, right, fourth generation wireless that we are now using, we call it LTE, and LTE Advanced has already been developed all the world. But 5G, right, the fifth generation wireless technology require a new standard to support these ultra fast, low latency services to customer. So what will be the key disruptive technology trends that enable 5G that engineer must face and overcome? So it depends upon who you ask, right? For me, I think the key enable technologies are as below. So as one first thing is the new radio standard for 5G. It's separate, it's different from LTE and it's defined by 3GPP standard. And another one is that millimeter wave and phase array antenna will become a norm. And this complexity will require 2 dB of baseline addition link budget. Because of millimeter wave, it get lost more in the air. And multiple input and multiple output, we call it MIMO, will offer significant gain in wireless data rate and link reliability. And the fourth one will be radio access network, called it RAN and core network. So how will legacy and how the legacy and the new 5G network architecture interact? So from the technology standpoint, this will mean higher frequency, wider bandwidth, and higher efficiency power amplifier is needed. Other needed components will be include low noise, floor RNA, quantized phase shifter, and also ultra low jitter clocks. Also low cost millimeter wave packaging also need to be developed, and also ultra high speed and low power AC to DC converter. Wideband antenna is need to develop, and millimeter wave antenna, a high gain directional antenna, and beamforming antenna need to develop and will become a norm.
So, Amos, how will people be viewing RF technology in 5 years as the technology continues to move forward and as 5G becomes more and more of a reality for a wider population around the world? How are people going to be viewing RF, and maybe what changes will occur that we will see and perceive RF in a different way moving forward?
Yeah, in my opinion, I think RF technology in 5 years will be synonymous, right, with 5G technology, as just how I mentioned. So 5G will be a super highway that will be taking the digital transformation to a new height, right? And it will be exciting to see the development that come with it. So I think 5G will bring advances in many areas. Here I would like to mention 5 areas that I see is a significant advancement. First will be smart factories, right? 5G will play a pivotal role in Industrial 4.0. So it's a technology that will connect devices and IoT. 5G will help also smart factory to do amazing things. And smart factory that will grow their use of robots powered by AI and machine learning that help them to make real-time decisions. And they will also be using more robots to dangerous tasks and helping keep employees healthy and safe. So we will see training become safer too, right? As smart factory bring augmented reality and virtual reality into the training routine. So allow employees to learn faster and safer than ever before. So the second area that I want to talk is also, we call it mixed reality. 5G, because of its increased speed and bandwidth, this will allow AR, right, or augmented reality and VR, virtual reality to expand. So soon, I think coupled with the 5G connectivity, we will see mixed reality explode with real-world application, right, from maps to business application, appliance application, and also virtual reality may finally come, right, the real virtual reality. And with 5G, we'll see AR and VR used in our cars, our phone, and even our own computer screen. So it will become a part of everyday life. The third area is autonomous vehicles. So 5G could be technology that finally push them out into a world, right? Safely, right? Safety is very important. So 5G is the only technology I think does fast enough to allow machine to mimic human reflex because of low latency. 5G won't roll out overnight, but once it's available everywhere and mature, I believe there will be no stopping the development of safe autonomous machine. And not just car, but I think trucks, buses, and even airplane as well. So the fourth area will be a smart city. So we all know that up until now, right, smart city haven't been very smart, right? They have pockets of intelligence like smart parking, lots, street light, but they haven't been able to hit a level of high connectivity that makes it consistent, mark an improvement in our daily life. So too much data on the 4G network and it's like using slow internet. Right? But with this 5G, again, it's the only technology fast enough to allow so many devices to connect at such high speed that the development of this technology will be worthwhile. Okay, and last, I think people also talking about edge computing. So edge computing also allow data to process as close to the source as possible because it doesn't travel as far. So it can be processed much faster and making things like autonomous vehicle safer to drive. And with the high speed, also low latency data transmission of 5G technology, the potential of edge computing will be fully realized in a wide variety of applications. So from smart city, like I just mentioned, and factories to retail environment and for real-time offer and analytics.
Well, it seems like RF technology is going to play a huge role moving forward as technology continues to develop, and in the technology that we commonly think of as, what's coming in the future. Everything from 5G to autonomous vehicles to smart cities, like you mentioned. And you also mentioned artificial intelligence. So what role does RF play in the development and the use of artificial intelligence?
Yeah, RF technology, talking about 5G, right, which will support the exponential high data load. So a key factor that in the evaluation of smarter AI, right, you can get more data, which access to richer data. The improved AI will boost 5G performance by enhancing security and reducing congestion and fixing network issue in real time. And with this 5G and AI working together, data will become more valuable than ever before. So I think that the working of RF technology and AI is currently is not so obvious in today's world, right? Yeah, it's just a lighter note here. Right? I like to watch movie during my spare time, so especially the science fiction movie. Example also include the Marvel cinematic world. So if you watch this movie, you can see some instant how this AI and RF technology work in perfection. But although sometimes it's unrealistic. But example, right? Watch Iron Man, right? A movie. So Tony Stark, the Iron Man, using this RF technology to communicate with his AI called Jarvis, right? To gather information as he's flying in his Iron Man armor suit and help him to fight the villain. So, well, this is far-fetched, I think, in the future. But with this 5G technology and the coming 6G technology, this may be even closer to realistic in the coming future.
That's a really great example. I love the example of Iron Man, and that's a fantastic way to put it, and something I hadn't thought of before. But I think that really brings the example home in a way that people can understand and can see how this could potentially work in the future. So, Amos, it's been an absolute pleasure getting a chance to talk to you today and learning a little bit more about RF technology. So, Amos Cheah, Senior Manager of R&D and Product Development Engineering at TE Connectivity. Amos, thank you so much for joining me today and giving us the rundown on RF technology.
Yeah, welcome. Hopefully y'all can learn something from this RF technology.
Well, I know I learned a lot today, and so I appreciate you joining us on Connected World. And everyone, thank you so much for listening to this episode of Connected World, a podcast from TE Connectivity. We appreciate it very much. Of course, make sure you go subscribe on Apple Podcasts or Spotify to make sure you get the latest episodes from TE Connectivity downloaded directly on your mobile device. And of course, we'll be back soon with more episodes. But until then, I've been your host today, Tyler Kern. Thanks so much for listening.